Welcome back. We are going to be looking at linear functions today. Going to split it up into two videos, focusing on what makes up a linear function and how it looks in a graph. So before we start, linear function. When we're thinking about a linear function, we want to identify, or we can always identify three things. The first thing is the slope. Now this is usually designated by the letter M. Why they say M? I don't know. It's something probably has to do with Latin. That's why it's not S or something else, but it's designated with the letter M. We can also, makes it really easy to identify the y-intercept. That's designated with the letter B. We can also represent it as something, comma, 0, comma, a number. It will always be 0, comma, that number. And later on, we will be able to identify or find an x-intercept. Now, unless the line is horizontal or the line is vertical, it will have all three of these things. We are first going to focus on slope, and then we're going to look at how we find our y-intercept. The x-intercept we'll worry about for another lesson. But we can always find, or should be able to identify, these three things with the line. Now, there's several forms we can explain a line in. The most common, the easiest to use by far, is the slope-intercept form. Now, why do they call it the slope-intercept form? Because we can easily see the slope and the y-intercept in this form. And you've seen this before. I'm sure you've had nightmares about it. But it is y equals mx plus b. Our basic form. Y equals mx plus b. Now, what the y value equals? That equals our output value. So you want to make sure you understand that. This y equals our output value, or the ending value of our function. Typically, there's not going to be a number in there, because we can always change it with whatever our input is. Our x will be our input value. Now, we've worked with x-y charts and so forth. This is where our x and y values would go. We have an m, which we already says is our slope, and our b value, which is our y-intercept. Okay? Please make this distinction. These y's are not the same thing all the time. This is the output value. The b is designated at the y-intercept, where it crosses the y-axis, and we'll talk about that in a little bit. But this is the basics of a linear function. This is what we should be able to identify, be familiar with, and be able to talk about on any given moment. Now, we're going to start with looking at slope. So we're always going to want to find slope. Now, if we're given 2 points, so our first problem is problem A. We have a point of 2, -3, and we have a point 5, 8. Now, in order to get slope, there's a formula we use. Please write this down. Have it handy. You're going to hear it 100 times this year. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, this is also the change of our y values over the change of our x values, or the change of our rise over the change of our run. So slope is rise over run, or the change of y over change of x, or this. This is our slope formula. Make sure you have that down. Now, when we're looking at these, remember in an ordered pair, the first number is the x value, the second number is the y value. Make sure when we're plugging it in, you keep the y's with the y's on top, the x's with the x's on the bottom. So I'm going to call this point 1, so I'm going to call this x1 and y1. This I'm going to say is point 2, x2 and y2. When we're looking at the points, it really doesn't matter which one you call point 1 and point 2, but they need to be consistent with the x's and y's. So I start here, y2 minus y1. So I have 8 minus, and remember this is a negative 3, over my x2 value is 5 minus 2. If we have a minus a negative, change it to a plus. Now it's a simple addition and subtraction problem. 8 plus 3 is 11. 5 minus 2 is 3. Now, we always want to leave it as an improper fraction. But we do want to see if we can reduce 11 over 3. And in this case, we cannot. So the slope of this, of a line going through these 2 points, is 11 over 3. Letter B. Four comma 9, 8 comma 11. So again, y2 minus y1, x and y, x and y. y2 is 11, y1 is 9, x2 is 8, x1 is 4. All positive numbers, so I don't have to worry about changing anything. 11 minus 9 is 2, 8 minus 4 is 4. In this case, 2/4. We can reduce this, and I expect you to reduce this to 1/2. So this means it's going to rise up 1 and go over 2. And then letter C. We have 15 and negative 4. And 5 and negative 6. So again, the y values. Negative 6 minus a negative 4 over 5 minus 15. Minus a negative makes it plus. So negative 6 plus 4 is negative 2. 5 minus 15 is negative 10. Now, negative over negative, those are going to cancel. And 2 goes into, can divide each of these by 2. 2 goes into 2 one time. 2 goes into 10 5 times. And there's our slope of 1/5. Now, we can, there are a couple other special slopes. As you saw, our slope can be a positive slope or a negative slope. There's 3 other examples, or 3 different possibilities of what our slope are. So here's letter D. Our points 3, 4, and 5, 4. Change of y's. 4 minus 4 and 5 minus 3. We get 0 over 2. If we end up with 0 divided by 2, check this in your calculator. You will get an answer of 0. This is a 0 slope. It means there is no rise, it just runs on forever. Now we're going to compare it with another example. Let's say we have 5, 7 and we have 5, 10. Now here, change of y's. 10 minus 7 over 5 minus 5. In this case, the zero's on the bottom. If If you plug this in your calculator, you will get some kind of error message where it doesn't work. And it's because one of the rules in math is we can never divide by 0. This is called undefined. So this will result in a vertical line. Again, remember, this violates the vertical line test that we talked about last class. So that's the algebra part of finding slope. y2 minus y1 over x2 minus x1. Now, what if we're given a graph? I have 4 graphs up here. Hopefully you can see them. I'm going to kind of bring this a little closer. So looking at number 1. Now whenever you're looking at slope, looking at a graph, we want to first identify, is it positive or negative? Read it like a book. Read it left to right. If I go left to right, I see that it is falling. So I know my slope has to be negative. It's got to be negative. Now, again, remember, rise over run. Look for where the line crosses the grid lines. I see it crosses here, in here, in here, and all the way down it's going to be the same way. I go down 1 and over 2. So this slope is negative 1/2. And you can continue. Down 1 over 2, down 1 over 2. Number 2, as I'm moving left to right, I am going up and over. Up and over. In this case, I'm going up 3 and over 1. So here, my slope is 3 over 1, or it is just 3. Now here's number 3. It's a horizontal line. How many units up am I going? 0. And at any point, I could say I'm going over 1, 2, 3, whatever. Remember, what's 0 over 3? It means my slope is 0. Number 4. It is going down left to right, so I know my slope is negative. Put a negative sign. Now, I'm going to make a little triangle here. I see I'm going down. I'm just counting the boxes. 1, 2, 3. Then I count over 1, 2, 3, 4. So, down negative 3 and over 4. So here my slope is negative 3/4. Please always count to the right, just like you're reading a book. Do not think that you have to go down and then left or either right. Always go up or down first and then to the right, and you'll always get the right slope. We will continue with the lesson with the next video.